So now let's go ahead and talk about solving linear inequalities. So x minus 5 is less than or equal to 7. So first we're going to find our critical value. So we're going to figure out when x minus 5 is equal to 7, because we know to the left and right of that x value, we're going to have points of change. So once I do a little algebra, I'm going to find that x equals 12. And because this is so important, I'm going to check before I do anything else to make sure that that actually works using substitution. Okay? We do see that that x equals 12 will make the two expressions equal. And it's important because if we get this wrong, none of this other stuff is going to work. So we always want to make sure that we got those critical values and we've double checked them. Once we do that, we're going to look at the intervals. So if these two expressions, x minus 5 and 7, are equal at 12, or at x equals 12, then we know that we have two real options. Our solutions are either going to be x is less than or equal to 12, or x is greater than or equal to 12. We know that 12 is part of the solution set because of the less than or equal to sign. So I graphed those out. Now I know that it's one or the other, and we're just going to test values. And as it turns out, as long as x equals 0, which is part of x is less than or equal to 12, or x equals 15, which is part of x is greater than or equal to 12, works in our original inequality, then we know that that entire interval is going to work as well. And we get negative 5 is less than or equal to 7. And we know that that is true, so we know that x is less than or equal to 12 works. Then when we try plugging in 15, we end up with 10 is less than or equal to 7. Well, that's clearly not true. So we know that that interval is not part of our solution set. And this is going to be the basis of how we solve all of these inequalities. Now, you could try another value just to double check it. But in reality, since we are sure that our critical values are correct, we can feel real confident that that is going to verify that our solution works. So let's look at a slightly more difficult example, but the process is going to be the same. So we're going to find out when these two expressions are equal, and that'll give us our critical value or values. Okay. And again, this is just some, relatively simple algebra. You can go back to some of the other videos if you are a little confused about this still, but we should be comfortable with this by now. And we find that these two expressions are the same when x is equal to negative 21. So we're going to double check that x equals negative 21 does make the two expressions equal, and it does. So we can feel confident we found the correct critical value. And then from there, we're going to look at our test intervals. So if these two expressions are equal at x equals negative 21, then our solution set is either going to be when x is less than negative 21 or when x is greater than negative 21. And the equals is not going to actually be part of the solution set because of that greater than sign. It's not greater than or equal to. So I graph out my solution sets on my number line, and now I'm going to pick some test values. Okay, so x is less than negative 21, negative 25 works for that, and x is greater than negative 21, x equals 0. I always pick 0 if I can, because it's easy to plug in and easy to manipulate. So I take my original inequality and I substitute in my test values. Okay, after a little bit of arithmetic, I find that 35 is greater than 27 is true, so x is less than negative 21 is a valid solution set. Now, when I plug in 0 to test my interval x is greater than negative 21, I end up with negative 15 is greater than 27. It's clearly not true. So I know that x is greater than negative 21 is not part of my solution set. And as it turns out, what we're seeing here is if we can solve an equation and we can do a little substitution, we can solve an inequality.